Okay, so this is the second video for Systems of Linear Equations notes. This is page 65 in our binders, and this is the back of that page. So there's a 65B for your binders. Okay, you'll remember that on the front of this page, you already had a system of linear equations graphed, and then we just found the intersection or whatever the solution was. This time, our graphs are blank. Instead, we are given two equations. Now, these look an awful lot like y equals mx plus b, which is a linear equation. And we know how to graph linear equations. So what we're going to do is we're going to graph this equation, then we're going to graph this equation, and then we're going to determine what the intersection is. So looking at the blue equation, I have y equals 2x minus 8. That is y equals mx plus b. Our beginning number is negative 8. So the y-intercept is negative 8. Find negative 8 on the y-axis. And the slope is 2. When we're graphing, we like the slope to be a fraction, so the denominator for any whole number is 1, because 2 divided by 1 gives us back the original 2. Remember that slope is rise over run, and we always run to the right first. So I'm going to draw a right arrow by the 1. The rise is 2, so we're going to go up twice. I went up because my slope 2 is positive. So from this beginning point, negative 8, we're going right once and up twice. And from that new point, we're going right once and up twice. From that new point, we go right once and up twice. And we're going to keep going right one time and up twice until we're out of room on the graph. So that's about right here. Now we go back to the beginning, negative 8, and we're going to do the opposite to go backwards. The opposite of right 1 is left 1, and the opposite of up 2 is down 2. So from that beginning point, we're going to go backwards by going left once and down twice until you run out of room, which we've done. Now I can connect those lines. Or those dots, sorry. Now that is one equation, but I have a system of linear equations. I have to graph the other equation. The other equation has a beginning point, or a y-intercept, of positive 1. So on your y-axis, find positive 1. Now the slope is negative 1 over 1. There's an invisible 1 right in front of the x because there's still one x here. Now we always run, so the bottom number, to the right first. Because this slope is negative, we're going to go down. So from this starting point, we're going right once and down once. Right once and down once. From that new point, we go right one time and down one time. And you keep going right once and down once until you run off of the grid. Right one and down one. Now that we're off of the grid, we go back to the beginning, and to go backwards, you have to do the opposite. So instead of going right, we're going to go left, and instead of going down, we're going to go up. From that beginning point, we're going left 1 and up 1. Left 1 and up 1. From that new point, left once and up once, and we're doing that until we run out of room on our graph. Then we can connect all of those dots to make the second line on our graph. Now I have a system of linear equations. I have two linear equations here. And the solution is wherever those two lines cross each other, which happens to be right here. There's just one solution. I can write that ordered pair to then x comma y. The x value is 3, and the y value is -2. So after you have both lines graphed, this is exactly what we did on the front of this page, just finding the ordered pair of the intersection. The trick is you just have to graph both of those lines first. Looking at example number 2, and I'm going to put the graph for that right here. I'll make this my blue equation. The y-intercept is 2, and the slope is -2, and I need that as a fraction, so the denominator is 1, because -2 divided by 1 is -2. So on the y-axis, I know we're going to start at +2. The slope is -2 over 1. We always run to the right first. Because this is negative, we'll go down. So from that ordered pair, we're going right once and down twice. From that new point, right once and down twice. And we keep going right once and down twice until we're out of room. Then we go back to the beginning and go backwards. Instead of right once, we're going to go left once. And instead of down 2, we're going to go up 2. Left once and up 2 times. And from that new ordered pair, left once and up twice. And you keep doing that until you're out of room. Now you can connect all of those dots to make the line. And we're ready to graph the next equation, y equals x minus 4. The beginning number there is a -4. The slope in that equation, the invisible number in front of x, is 1, and it's positive. I need it to look like a fraction, so I have 1 over 1. So on the y-axis, we find -4. And then to go from one point to the next, the run is 1, and we always run to the right. Then we rise. This is a positive slope, so I rise up just one time. So from this ordered pair, we're going right once and up once. From the new point, right once and up once. Right once and up once, and you do that until you're out of room on the grid. Then you go back to the beginning and go backwards. So instead of right once, we go left. And instead of up once, we go down. Left one and down one. Left one, down one. Until you're out of room. Then you can connect those 2 points, or sorry, those many points. Now you have a system of linear equations because there's 2 or more linear equations. This has just one intersection. I can see where the lines cross. So there's one solution. I can write the solution then as an ordered pair, x comma y. The x value, remember that's the side-to-side number, is 2. The y value is the up and down number, which is -2. So the ordered pair of the solution to the blue line and the pink line, the system of linear equations here, is 2, -2. Looking at example number 3, I'm going to put example number 3 in this box. Here's what I'll call my pink line. the beginning number is 4, and the slope is 1 over 3. So we're going to start at a positive 4 on the y-axis. We always run to the right first, so the run on the bottom is 3. We're going to go right 3. Because this is a positive 1/3, we're going to go up. So from that point, we go right 3 times and up once. Right 3 and up once. And you do that again and again until you run out of room. Now we go back to the beginning and go backwards, so we have to do the opposite things, which is going left 3 and down 1. So from this point, we're going left 3 and down 1. Left 3 again and down 1 from that new ordered pair. And again, left 3, down 1, until we run out of room. Okay. Now I'm ready to graph the next line. We'll graph that one in blue. The beginning, or the y-intercept, is -1. So on our y-axis, we plot -1. Now to go from one point to the next, we use our slope, which is 1 over 3. We always run to the right first. So we put a right arrow by the bottom number, which is 3. Because this is positive, we're going up. So from that ordered pair, we're going right 3 times and up once. From this beginning point, we go right 3 times and up once. Right 3 times and up once. From that new point, we go right 3 times and up once until you run out of room. Then you go back to the beginning point, and instead of going right 3 up 1, you have to go left 3, and the opposite of up is down. So left 3, down 1. From that starting point, left 3 times and down once. Left 3 times and down once. And we do that until we run out of room. And now we can connect our 2 lines, or our dots. And then we'll have 2 lines or a system of linear equations on our graph. What we've got here is 2 parallel lines. And I know that with parallel lines, that means they're never going to cross, which means there are no solutions. Remember, another way you might see that is 0 solutions. I'd like to point out why that happened. In the pink line, if I went up once, then I also went over 3. In the blue line, if I went up once, I also went over 3. These 2 equations had the same slope, and they started at different points. So every time the blue one went up, the pink one also went up the same amount of spaces. Every time the blue one went to the right, the pink one also went to the right the same amount of spaces, which means these never touched because they moved the same direction at all times. So if the slopes are the same, or equal, then there is no solution or 0 solutions. Because you get parallel lines. And then we'll graph the last problem in this box. So example 4. I need to graph y equals 2x plus 3. The beginning point there, the y-intercept, is 3. So on the y-axis, we find 3, and that's our beginning point. The slope is 2. I need that as a fraction, so I'm going to put 2 over 1, because the denominator in whole numbers is always 1. This is rise over run, and we always run to the right first. Since this is positive, I'm going to rise up. So from the starting point, we go right one time and up twice. Right one time and up twice. From that new point, we go right once and up twice until we run out of room. Then you go back to the beginning and do the opposite. So instead of right once, we're going to go left once. And instead of up 2, we're going to go down 2. From the beginning point, we're going to go left once and down twice. From that new point, left once, down twice. And you keep going left once and down twice until you're off of the graph. My timer went out. Left once, down twice. And then I can connect all of the dots to make that line. Now I'm ready to graph the second equation in my system of linear equations. Because this is a linear equation, it looks like y equals mx plus b. So the beginning point, or the y-intercept, is -2. So on the y-axis, we find -2. The slope is the number in front of x, which is 3 over 4. That is rise over run, and we always run to the right first. Because the slope is positive, we will go up 3 times. From the starting point, we go right 4 times and up 3 times. To the right 4 times and up 3 times from that second new point. And you would keep going right 4 and up 3 until you're out of room. Then you go back to the beginning and do the opposite to go backwards. The opposite of right 4 up 3 is left 4 and down 3. From that beginning point, we go left 4 and down 3. From that new point, left 4 times and down 3 times. Left 4 times and down 3 times until you're out of room. Then you can connect those dots. And the intersection happens right here. Since I can see the intersection, I know there's only one solution. So I can write the ordered pair x comma y. The x value is the side-to-side number, which is -4. The y value is the up and down number, which is -5. And that is all of the examples in today's notes. Take a look at your homework on page 66 and look at number 3. Now this top line, you guys know how to graph. The y-intercept, or the beginning point, is a 1, and the slope is -1 over 1. And you know how to use these two things to draw the line for that linear equation. Looking at the next equation, that is not a linear equation. That says x is equal to 3. I know it's not a linear equation because it doesn't start with y. It says x equals 3, which means x is always 3. So on the x-axis, find x equals 3 and put a dot. Let's just pretend that I have an ordered pair and it's -4 for the y value. In this equation, x is always 3. So we'd have 3 -4. Let's pretend that I have a positive y value of 2. In this equation, x is always 3. So the ordered pair would be 3, 2. If you draw a line connecting those points, it just goes straight up and down. It's a vertical line. And vertical lines have undefined slopes, and they're not linear equations. This, I know, isn't a linear equation because it starts with x. It's undefined because it starts with x, and it should start with y. I just wanted to help you guys graph that line because you haven't seen very many x equals some number. So now that that's graphed, you can graph that one on your own and find the intersection there. Actually, this slope is negative, so me drawing this way is wrong. It would draw that way somehow. If you have any questions or concerns, feel free to reach out to me on Schoology or drop a comment on this video, and I will get back to you as soon as I can.